This recording is to go over the answers from our test. The first question is to find the geometric mean between 2 and 5. The geometric mean is always the square root of the product of the two numbers. So 2 times 5 equals 10, so our answer is the square root of 10. Our next question, we are going to use similar triangles because we have a large triangle and a small triangle which happen to share some sides. So I'm going to label this side y because this side happens to be in our smallest triangle and our largest triangle. And because I have the two other sides of my small triangle, this 4 and 6, I can find y using the Pythagorean theorem. So y squared equals 4 squared plus 6 squared. Y squared equals 16 plus 36. So y equals the square root of 52. Now when I look at my triangles, I find out that the small side of my small triangle is 4. The small side of my large triangle is y, so that's going to be the square root of 52. The hypotenuse of my small triangle is y, which is the square root of 52. And the hypotenuse of my long triangle is this x that I'm looking for. So I can set up this proportion. And then I cross multiply. I get 4x equals, when I multiply the square root of 52 times the square root of 52, those square roots drop out and it just ends up being 52. 52 divided by 4 is 13, so x equals 13. My next question is very similar because I have a small triangle and a large triangle that share some sides. So they both share this side right here. This is the hypotenuse of my small triangle, and it's the short side of my long triangle. I also have the short side of my short triangle. So I'm going to put the short side of my short triangle, which is 2, over the short side of my large triangle, which is x. I'm going to set that against the hypotenuse of both triangles. The hypotenuse of my small triangle is x. And the hypotenuse of my long triangle is this whole side here. So it's 2 plus 12. So it's going to be 14. Then I can cross multiply, and I end up getting x squared equals 28. So x squared is the square root of, or x is the square root of 28. So you could either have written down the square root of 28, or if you pull a 4 out of this, the square root of 28 would equal 4 times 7, the square root of 4 times the square root of 7. The square root of 4 is 2, so I can actually pull that 2 out, and I can rewrite my answer as 2 times the square root of 7. My next problem, number 4, is just a very simple application of the Pythagorean theorem, because I have a right triangle, and I have the two shorter sides. So I can, x is my hypotenuse, so x squared equals 60 squared plus 20 squared. So that's going to turn into x squared equals 3,600 plus 400. When I add those together, I get x squared equals 4,000. So x is going to equal the square root of 4,000. And if I want to take out a radical on that, this can turn into 4 times 10 times 100. So if I take out the square root of 4, I get 2. If I take out the square root of 100, I get 10. So 2 times 10 is 20. And then inside I just ended up left with the square root of 10. Let's look at number 5. When I have an equilateral triangle and I bring down an altitude or a height for that triangle that forms a right angle with the bottom, I end up splitting this side into 2 equal sides. So now I just have 2 separate triangles that have x, a hypotenuse of 20, and a short side of 10. So once again, I can use the Pythagorean theorem. So this time my hypotenuse is 20, so 20 squared equals x squared plus 10 squared. And then I work out my algebra. I get x squared equals 20 squared minus 10 squared. And when I do all of that work, I end up getting the square root of 300. Or, if I want to take out my 100, the square root of 100 is 10, and I'm left with the square root of 3 inside. Number 6, I've kind of covered up my x there, but I'm looking for the length of one of these sides, which is x. I see that all the sides are equal, so I'm looking at a square, and 22 is my diagonal, which is also the hypotenuse of one of these triangles. So if 22 is my hypotenuse, 22 squared equals x squared plus x squared, which is also equal to 2x squared. So if I divide both sides by 2, well, first let me go ahead and multiply out 22 squared. I'm going to use a calculator. 22 squared equals 484. So let me find my magic pen. So 484 equals 2x squared. I divide both sides by 2. And I get x squared equals 242. So x is going to equal the square root of 242. And if I simplify that and take out a radical, I end up that I get inside of here 11 times 11 times 2. So I can take out one of those 11s. I get 11 times the square root of 2. We're going to go ahead and move my page down before I look at the next problem. So my next problem, I'm given a diagram of a parallelogram, and then I'm given some additional information that I add in. So side AD right here, I'm told is 4, and then angle D, I'm told is 60 degrees. So now I'm working with a 30, 60, 90 triangle. And you'll remember we had those up on the board, so I'm going to paste that here. So this is our 30, 60, 90 triangle theorem. And I'm going to look at how I've got just my 30, 60, 90 triangle right here. I'm going to redraw just that small triangle. So I have this side that comes down and forms a right angle. I go across to here. So across from my right angle is the hypotenuse, which they gave me is 4. And then this is my 60-degree angle right here. So now if I look at my 30, 60, 90, I see that 2x equals my hypotenuse. So I'm just going to solve for what x is in this first before worrying about anything else, because the only thing that I know is the the 4 of my hypotenuse over in this diagram. I've lost my pen. Here we go. So that means 4 equals 2x. So x equals 2. Now going back over here, I see that x is my short side, and then this length is the square root of 3 times x. So my short side is across from my 30, and this side is across from the 60. Well, if I go back to my original diagram, it asks me to find AF, and AF is across from my 60. So again, across from my 60 is the square root of 3 times x. I've already found that x is 2, so that means that I just plug in x for 2, and it's the square root of 3 then times 2, but I'm going to write the 2 in front because that's how we write radicals. So that's my simple answer for number 7. For number 8, I'm given everything I need to know right on my diagram, and I see that again I've got 30, 60, 90 triangles. And they're also similar triangles, and they have some shared sides. So the only triangle that I know, or that I have at least some kind of marking for 2 sides, is this little triangle right here. So I'm going to redraw that little triangle so that I can see it a little better. So when I redraw this, my hypotenuse is 4 times the square root of 3. My short side, I'm not given any information on, and this longer side, which is across from the 60-degree angle, is x that I'm looking for. So when I go back over here to my 30, 60, 90, I see that the hypotenuse is 2x. Well, I want to use a different variable to solve for x on my 30, 60, 90 because I already have an x in my diagram. So I'm just going to call this 2 times L. That's what I'm going to rename this side. 2 times L. And then this side then will be L, and this side will be L times the square root of 3. So now if I go back over here, as soon as I find my pen, if I go back over here then, I've got 4 times the square root of 3 is equal to 2L. So I put that in here, 4 times the square root of 3. So I want to get my L by itself. So L equals 4 times the square root of 3 over 2. And I can put that 2 right in with here, with my 4. I can divide that 4 by 2, and I'm just left with a 2 now that goes out in front. So that means my L is just 2 times the square root of 2. And L is the side across from the 30-degree angle. So I'm just going to go ahead and write that in. 2 times the square root of 2. And now x that I have here, if we remember, x is what's across from the 30-degree angle. So x is whatever L is times the square root of 3. Well, this is L. So I'm going to go ahead and write over here. So x equals L times the square root of 3. L equals 2 times the square root of 3. I miswrote that. Now I didn't clean it up very well. I'm going to see if I can clean that up a little better. There we go. 2 times the square root of 3. So if L equals 2 times the square root of 3, then x equals 2 times the square root of 3 times the square root of 3. And when I multiply these two together, it just ends up being 3. So x equals 2 times 3. So x equals 6. So I'm going to go ahead and write that on my answer line. X equals 6. And now I need to find y. I'm going to go ahead and draw this next triangle over here. So I have side x, this line here, which I don't know why that didn't draw, there we go, this line here, and then I have a hypotenuse, which is y. This was my x side, which I just found out equals 6. This side I don't know, but that's okay. This is my right triangle. This is my 30-degree angle. So if I look back at my triangle here, the side across from the 30-degree angle, I'll bring this out because I like that bigger cursor, the side across from the 30-degree angle is equal to, again I'm going to say L, is equal to L, and then my hypotenuse is equal to 2 times L. So nice and easily then, y equals 2 times 6, which equals 12. I'm going to go ahead and scroll down again some more so that I can get my 9 closer to the top, which is the next one I'm working on. So 9, after we've done a lot more complex problems, is just going to be a simple application of SOHCAHTOA. I know that it's going to be SOHCAHTOA because it's a right triangle, and to use SOHCAHTOA you have to have a right triangle. I'm just going to write that down. So SOHCAHTOA only with right triangles. So I can use it here. So this is what I'm looking for. This is my opposite side, this is my adjacent side, this is my hypotenuse. So I'm looking for my hypotenuse and I have the adjacent, which means I'm going to use cosine, because cosine is adjacent over hypotenuse. So I'm going to go ahead and write down my equation over here. So that means the cosine of 18 degrees equals my adjacent, which is 9.2, over my hypotenuse, which is x. So then doing some algebra, I'm actually just going to swap these two, because I'll end up multiplying this side by x, and then I'll divide it by cosine of 18. So x equals 9.2 divided by the cosine of 18. So I'm going to go ahead and put that into my calculator. Here's my calculator. So my calculator, I put things in a little bit differently than your calculators. So I'm going to do 9.2 divided by, and then again my calculator is a little weird the way I have to put this in. So then I get 9.67, which I'm going to round up to 9.7. So I'll go ahead and write that in here, is 9.7. For my next problem, I'm given information that I'm starting with an A-frame house. It has a 40-foot height and a 30-foot base. And it wants me to find this angle here that the floor makes to the roof. So the easiest way for me to do this is to drop down an altitude, which is the height of the triangle, and we remember that a height always forms a right angle to the base, and because this is an isosceles triangle, that means that height is also going to bisect the base. So now I've got two separate 15-foot sides. And the height, I've already been told, is 40, so this line right here is 40. So now I have a triangle. It's a right triangle. It has one side with a length of 40, one side with a length of 15, and this is the angle I'm looking for right here. So now that I've set up my problem, since this is a right triangle, I can use SOHCAHTOA. So I have my opposite and my adjacent. So that means I'm going to use tangent. So tangent of angle X that I'm looking for equals my opposite of 40 over my adjacent of 15. And then to get this X by itself, I have to use the inverse tangent. So X is going to equal the inverse tangent of 40 over 15. Now again, with my calculator, I have to put things in a little differently. I'm going to open up my calculator. I'm going to put in 40 divided by 15, and then I'm going to take the inverse tangent of that. And I get 69.44, and it says in my question that they want me to round to the nearest degree. So 69.44 rounded to the nearest degree, if I can find my pen, is just going to equal 69 degrees. Now let's go ahead to the last problem. We have a tree that's 30 feet tall. It casts a shadow that's 12 feet. And it wants to know what is the angle of the elevation of the sun to the nearest degree. Remember, angle of elevation is always above my horizontal. So that means I'm finding this angle right here, that when the sun comes through the tree and it casts the shadow, it's formed right here. Well, I know that the height of the tree, we're assuming this tree grows perfectly straight, is going to be at a right angle with its shadow. So once again, I've got a right triangle, and I have my opposite over my adjacent. So again, I'm going to use tangent. So tangent of X equals 30 over 12. So X equals the inverse tangent of 30 over 12. I'll put that into my calculator. 30 divided by 12, and then I take the inverse tangent, and I get 68.19. Again, it wants me to round to the nearest degree, so when I round that to the nearest degree, I get 68. So that's 68 degrees. Let's go ahead and scroll down for the next question. Just going to move this over a tiny bit. There we go. So our next question, it says a boat is 100 meters from a cliff. If the angle of depression from the top of the cliff to the boat is 15 degrees, how tall is the cliff? Now a lot of you, when you solve this, you looked for this angle right here. But we need to remember the angle of depression is down from the horizontal. So this is the horizontal. So this right here is my angle of depression that I'm looking for. So I'm going to fill in the information I know. We already have the boat is 1,000 meters from the cliff. We don't know the height of the cliff. That's what we're looking for. And we know that this angle right here is 15 degrees. So I can either know that this line and this line are parallel, and I can look for corresponding angles, or if you want, you can just redraw the cliff edge over here. So now we have two triangles. This length across here is also going to be 1,000 meters, and this is X that we're looking for. We have a right triangle. This is our angle, and again, if we're going to use our trigonometric functions, we have the opposite side and we have the adjacent side. So once again, we're using tangent. So tangent of 15 degrees equals my opposite over my adjacent. So the altitude then is going to equal, or the height of the cliff is going to equal x, which is 1,000 times the tangent of 15. So I'm going to put that into my calculator. So I'm going to get my tangent of 15, and I'm going to multiply that by 1,000. And I get 267.94. It says round to the nearest tenth. So it's 9.4. It's going to round down or stay at the 9. So my answer then is 267.9. So we have a similar problem here. Number 13, it says a plane flying at an altitude of 10,000 feet. So I'm going to start to draw that here. This is 10,000. And here's my plane up here. It begins to descend when the end of the runway, so it's beginning to descend, when the end of the runway here is 50,000 feet from a point on the ground directly under the plane. So that means this length here is our 50,000. It says, find the measure of the angle of descent or depression from the nearest degree. Once again, the angle of depression has to come down from the horizontal. So I'm going to just draw out my triangle. So this is the angle I'm looking for. So I'm going to write back in the information I know. This is 50,000. This is 10,000. This is going to be a right angle. And once again, we're going to end up using tangent because this is our opposite and this is our adjacent. So tangent of, I'm going to call this x. Tangent of x is going to equal the opposite over the adjacent. So inverse x is going to equal the inverse tangent. And I'm actually going to simplify this right now. It's 10,000 goes into 50,000 5 times. So it's going to be the inverse tangent then of 1 over 5. So I'll put that into my calculator. 1 divided by 5 inverse tangent equals 11.30. It wants me to round to the nearest degree, so that's just going to end up being 11.3 degrees. Oh, to the nearest degree, not the nearest tenth, sorry. Just 11 degrees. Let's go ahead and scroll down again some. Okay, so our next triangle, a lot of you tried to use SOHCAHTOA here, but you can only use SOHCAHTOA on a right triangle, and I don't have any right triangles indicated. What I have are 2 angles and a side. So with angle, angle, side, I'm going to use the law of sines. I'm going to go ahead and do my work over here on the right side. So law of sines is that the sine of A over A equals the sine of B over B. So just to help me visualize things, I'm going to go ahead and label my triangle. I'm going to call this one A, this one B, and this one C. So the side that I have is little a. So that means I need to know big angle A. Well, the nice thing is they gave me the other 2 angles, like I said. So angle A is just going to equal 180, the total degrees in a triangle, minus 37, minus 52. So we'll go ahead and use our calculator. 180 minus 37 minus 52 equals 91. So angle A equals 91. So I'm just going to go ahead and write that 91 in here. So now I'm going to go ahead back here. I'll finish my formula because the way that I labeled my triangle, I also need C. So now I have angle A, I'm looking for side A, and I have angle C, and I'm looking for side C. So I'm just going to go ahead and write those in. So sine of A over A equals sine of C over C. So in this case, that's going to end up being sine of 91 over X equals the sine of 37 over 26. I'm going to cross multiply. So I get 26 sine 91 equals X sine 37. I'm going to divide both sides by sine of 37. So I'm going to get X equals 26 sine of 91 over sine of 37. So I'm going to go ahead and put that into my calculator. Move my calculator over. So again, my calculator, I have to put things in weirdly. So I'm going to do 91, which was already there if I wanted it, the sine of it. And then I'm going to multiply that answer by 26. So I get this 25.99. And then I'm going to divide that, and I have to put my things in parentheses, by 37 sine equals 43.19. And it says to round to the nearest tenth, so it's going to be 43.2. So my answer is 43.2. Now my next two problems are also going to use the law of sines. And again, here I've got two angles, two sides. I have a 23-degree angle with X across from it. So I know I'm going to end up with sine of 23 over X. And my other side that I have is 7. So I'm going to put that down here. But it's going to be the sine of this angle. So again, I have to find out what that angle is. So 180 minus 146 minus 146 minus 23 is going to give me my other angle. I'll put that into my calculator. So 180 minus 146 minus 23 leaves me with 11 degrees. So over here, my angle is 11 degrees. So that means, let me put 11 degrees. That means here it's the sine of 11. And again, I have an angle side. That's why I have to use law of sines. I'm going to finish my work over here. I'm going to cross multiply, so I end up with 7 sine 23 equals X sine 11. I'm going to draw a little line here to make sure we can see what we're working on right now. I'm going to divide both sides by sine of 11. So X is going to equal 7 sine of 26 over sine of 11. And I'll put that into my calculator. 26, find the sine of it, multiply that by 7, and then I'm going to divide that by 11, the sine, and I get 16.08, and it says round to the nearest tenth, so I'm going to get 16.1. So I'm going to go ahead and write my 16.1 in right here. Now my next question is also going to use the law of sines. And it's asking me So the tree grew at a 3% or 3-degree slant from the vertical. So it's a slant from the vertical. The vertical would have gone straight up and down. So it's just 3 degrees more. So that's why this angle is 93 degrees, which kindly they filled in for us. At a point 50 feet from the top of 50 feet from the tree, sorry, the angle of elevation to the top of the tree is 17 degrees. So again, angle of elevation has to come off of the horizontal. Now it says find the height of the tree, which they've already labeled for us as x. So we don't have a right triangle. We cannot use SOHCAHTOA. But again, we have angle, angle, side, which means we can use the law of sines. We have x is across from our 17-degree angle. And we don't have anything across from our 93-degree angle, but we do have this 50. So once again, we're going to find our missing angle. So our missing angle is going to equal 180 minus 17 minus 93. So I'll put that into my calculator. Whoops, which just went away. Sorry about that. Put that into my calculator. It's 180 minus 17 minus 93 equals, so that's going to be a 70-degree angle. So I'm just going to go ahead and write that 70 in here. So now I can set up my equation. So sine, actually I'm going to put that where I can write it with a little more space. Sine of my 17 degrees over the height of the tree, x, is going to be equal to sine of 70 over 50 feet. I'll cross multiply. I get 50 sine of 17 equals x sine of 70. Divide both sides by sine of 70. So I end up getting x equals 50 sine 17 over the sine of 70. I'll put that into my calculator. So 17 sine of it times 50 equals, I'm going to divide that by 70 sine of it, and I get 15.55, and the question asks me to round it to the nearest tenth of a foot, so it's going to be 15.6. So I'll go ahead and write that in here, 15.6. Let's go ahead and scroll up again. So my next triangle then, number 17, I have 3 sides and I'm looking for an angle. So when I have side, 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 I use the law of cosines. So I'm going to go ahead and label my sides and my vertices. So I'm going to call this A, I'm going to call this B, I'm going to call this C. So that means the sides across from it get the same letters but small, lowercase. So this is side C and this is side B. So I'm looking for B. Over here, I'm going to write out my law of cosines. And in this case, I'm looking for angle B, like I said. So I get side B squared equals side A squared plus side C squared minus 2 times A times C times the cosine of angle B. And I've got a lot of algebra to do because what I'm trying to do is to get this B all by itself. So I'm going to go ahead and plug in my numbers. So little b is equal to 5. 5 squared is 25. Little a is equal to 11. So a squared is 121. Little c is equal to 5. I'm sorry, little c is equal to 7. So 7 squared is 49. So that means plus 49 equals 2, or I'm sorry, not equals, minus 2 times 7 times 11 times the cosine of b. So I'm going to go ahead and simplify some of this. So 25. I'm going to go ahead and be a little bit lazy and do my math on a calculator. 121 plus 49 equals 170. I'm going to go ahead and write my 170 down. 170 minus 7 times 11 is 77. 77 times 2 is 154. So it's minus 154 times cosine of b. Now I'm going to start doing some algebra to start picking away the things that are on this side with b. So the very first thing I'm going to do is subtract 170 from both sides. So 25 minus 170 equals negative 145. I've lost my cursor for a moment. Here we go. So negative 145 equals negative 154 times cosine of b. So the next thing that I need to do is to divide both sides by negative 154. I'm going to go back to my calculator. Actually, no, I'm just going to leave this like it is for a moment because I'm going to get a more accurate result if I don't divide 145 by 154 yet, because eventually I'm going to end up using trigonometry with it. So now to get b by itself, I need to use the inverse cosine. So I'm going to multiply this by inverse cosine. Multiply this side by inverse cosine. So now b equals the inverse cosine of negative 145 over negative 154. I'll just put that into my calculator. I'm going to go ahead and cross out my negative signs because I know they're going to cancel out. So in my calculator, I have 145 divided by 154 equals, and then I'm going to do the inverse cosine. So I get 19.68. It asks me to round to the nearest degree, so that's going to round to 20 degrees. Number 18 is actually going to be very similar, except we have to draw our triangle out for ourselves. So they give us triangle XYZ. I'm just going to go ahead and draw X, Y, Z. And remember, capital letters are the angles and small letters are the sides. So X, my angle X equals 152. Side Y, because it's a lowercase y, so side Y is the side across from here. Y equals 15, and then Z equals 19. And I'm asked to find this, side X, to the nearest tenth. So again, I'm going to use the law of cosines because I have two sides and an angle. And if I wanted to use the law of sines, I would need I would need at least two angles. So I'm going to go ahead and use my law of cosines, but I'm going to substitute in x, y, and z for my letters. So what I am looking for, it says, is x, which is good because the angle they give me is big X. So I'm going to write out my equation then. So I want to find x, so x squared, I'm starting way over here because it's a long equation, equals 15 squared plus 19 squared minus 2 times 15 times 19 times the cosine of 152. So I'm going to go ahead and just start filling in what some of those numbers are. So I'm going to bring up my calculator again. So 15 squared is 225. And 19 squared is 361. So 225 and 361. I'm going to go ahead and write those down. X squared equals 225 plus 361 minus, and I'm going to go ahead and do my 2 times 15 times 19. 2 times 15 times 19 equals 570. So it was 570 times cosine of 152. And again, I'm just going to keep on plugging away with my math. So x squared equals, let's find out what 225 plus 361 is. 225, oops, I didn't quite get that in there. 225 plus 361 equals 586. So 586 minus 570 times cosine of 152. So I'm going to go ahead and put that into my calculator now. So 152, the cosine of it is negative 0.88. And then I'm going to multiply that by 570, but it's negative 570. So I get 503. Then I'm going to add my 586. So I get 1089 is going to be x squared. So I'll go ahead and write that down. X squared equals 1089, but remember we've got x squared, so x equals the square root of 1089. Let's see if that's a round number or if we just want to leave it like that. 1089, since I've got all of my additional digits out here, I'm just going to go ahead and leave those. The square root of it is almost perfectly 33. So my answer, rounded then, is 33. It says to the nearest tenth, 0.0. Number 19 is one of our long vector problems. I'm going to scroll down, give us a little bit more space again. So number 19, I'm going to go ahead and do over here. So I have vector AZ. So it goes from point A to point Z. I'm going to draw my little reference of the diagram of the vector. It starts from 8, 8, which I'm going to say is right here. So this is A. Oh, I don't know why that's doing that to me. Just draw me a dot. There we go. And now it's going to go to 1, 3. So 1, 3. And then I'm going to is going to be around here. So this, poorly drawn though, is my vector. Oh, I was about to use my magnitude formula, but as you can see I paused for a second because I accidentally wrote b down here instead of z. Now back to my magnitude formula. My magnitude, I use the distance formula, so it's going to equal the square root of x2 minus x1 squared plus y2 minus y1 squared. So I'm going to plug those values in. My y2 value comes from z, so that's going to be, sorry, my x2 value comes from z, so it's going to be 1, and my x1 value is 8. My y2 value is negative 3, and my y1 value is also 8. So then I get the square root of negative 7 squared plus negative 11 squared. That's going to give me the square root of 49 plus 121. I'm going to go ahead and put that into my calculator. Move my calculator up here. So 49 plus 121 equals 170. The square root of that rounds to 13.0. So I'll go ahead and write my answer here. 13.0, and I'm going to go ahead. Oh, I already wrote it there because I had done a little bit of work and gone back, so surprise, it was already written up there for you guys. And then the next thing I need to do then is find my direction. Remember, the direction is always going to be from the positive x-axis. So that's why I drew this whole big line in. But the only thing I can find is this tiny little angle. So I have to find this angle plus 180 degrees to find my whole direction. So I'm going to call this angle x. So over here I'm just going to make a note to myself that x is going to equal, that my direction is going to equal 180 plus x. But going back to x then, I can figure out what my distance is here and what my distance is here, so I can use tangent of the change in y over the change in x. So I'm going to write that down. So tangent of my little angle x equals y2 minus y1 over x2 minus x1. And if you remember from the formula, this is within absolute value signs. So tangent of x equals, and I already got my y2 and y1 over here, so that's nice, I can kind of steal them, equals the absolute value of negative 11 over negative 7. These cancel out, I get a positive number. Since it's positive, I can just kind of ignore my absolute value signs. So now I need to use inverse tangent to get x by itself. So x is going to equal the inverse tangent of 11 over 7. I'm going to put that into my calculator. 11 divided by 7 equals, and my inverse tangent of that is 57.52. So I'll go ahead. Then over here, I'm going to end up with 180 plus 57.52. So I'll put that back into my calculator. Plus 180 equals 237.5. So I'm going to go ahead and write in that answer, 237.5. Whoops, I should have put that there. I'm sorry, I just put that in to my space for my next problem. So 237.5 degrees is my direction. Number 20 is just vector addition. It asks you to copy the two vectors and add them together. So here's vector S. Remember, when we're doing vector addition or subtraction, we always have to go tail to head. So here's the head of S, and from there, I'm going to start at the tail of T, draw T, which shouldn't have gone down quite so far. And then my new vector goes from the tail of one to the head of the other. So this is my answer right here. Finally, the bonus question. The bonus question is very similar to some of the early triangles that we looked at, but the fun thing is, we're going to end up using a quadratic equation, or at least solving for two options for x. So I have a small triangle that shares some sides with a large triangle. So my small triangle has a hypotenuse of the square root of 6. My large triangle has an hypotenuse of x plus 5. And since I'm setting up a proportion, my small triangle has a small side of x, and my large triangle has a small side of the square root of 6. So far I've just set this up like some of my other ones. I'm going to cross multiply. Square root of 6 times the square root of 6 just ends up equaling 6. And then I'm going to have to, when I cross multiply, I'm going to have to distribute this x. So let's go ahead and just write it first like this, and then I'll distribute it. So 6 equals x squared plus 5x. So now to solve for x, I want to go ahead and turn this into a trinomial, or turn this into a quadratic equation. And just to help make sure we don't get any confusion in here, I'm just going to kind of box out the rest of this work. So the first thing I want to do is I want to set this equal to 0, because to solve this quadratic, I need to find out what values of x can make the equation true, and the easiest way to do that is to set it equal to 0. So I'm going to subtract 6 from both sides. So then I end up with x squared plus 5x minus 6 equals 0. And then I'm going to factor that, and that is going to factor into x plus 6 times x minus 1 equals 0. Anything times 0 equals 0, so I'm going to find out which of these two factors, like what x equals when I set them equal to 0. So I'm just going to try x plus 6 equals 0, so that would have to be x equals negative 6. Well, I can't have a length of negative 6, so I know x cannot equal negative 6. What if I do x minus 1 equals 0? Well then, x equals 1. That works because that's a positive number. So my answer for the bonus is x equals 1. And that is a review of the test, just a few seconds short of an hour.